like a tick. If you write about batteries, you got to talk about dendrites.
One of the most tilting things that I came across in doing this research, which I think should get you your PhD stripped, is not defining terms. Like so many of the academic articles, they'll use a bunch of terms and they just won't even put the glossary in. It's like, come on, guys. I'm sure you have a running glossary. It's not that hard. And like, I want to see like your definition of it so that, if I go Google it, I'm not going to get the wrong impression. Though I'm sure some of them are very standardized, but you never know. That was one thing university, like sciences, taught me. Just define your terms. If you don't do that, you're a moron.
Pretty much, yeah.
It really is one of the biggest things. Like, I think so many academic writers, it's just like your shit's never going to get like any sort of real impact because you write it in such an annoying jargon-filled manner that it's incomprehensible to even like relatively intelligent people who just they want to learn
Did you
more.
ever consider that might be the point?
That's why Steven Pinker wrote The Sense of Style, because he was so sick of his scientific colleagues doing that. He's like, no, you want your information to be disseminated, so write it so that people can understand it. Like, you don't have to dumb it down for like the average person who's never going to read it anyways. But he's like, you should make it more accessible because that way it actually spreads more quickly. But
You want people to have at least 6 years of university under their belt before they get the jargon. Otherwise, how do you gatekeep it properly?
yeah, that's exactly it. It's like, we like our little language, and if you don't know these terms, well, Elon Musk actually banned that at Tesla. He was just like, stop it. Like, stop. I think, no, it might have been SpaceX. It was one of the two where he wrote like a company email saying, stop using like abbreviations and jargon because it impedes the onboarding of people. And we can't like communicate as effectively within the teams and externally. So stop it. It's like, that actually makes
Yeah,
sense.
but then what would you have to bitch about?
Exactly.
Half the work conversations are bitching about acronyms that don't make sense.
Bring some people together. Team building.
Yeah, exactly.
Crushing the water cooler talk.
Making yourself feel real good about all the little insider information that you got. All right, so with all that, we're jumping into the next topic. So that is the battery wars, as we've titled it. Basically, we're looking at the newer technologies of primarily like lithium-based batteries, and just like the pitfalls of them and what other battery technologies are coming along, given that the world is now racing towards a basically like an electrified automotive sector, looking to implement green technologies that require big battery storages, that type of thing. We're mostly going to focus on the EV side of things, but we'll kick it off here with just the general issues with batteries as they currently stand, and then we'll move into discussions about like the newer solutions that are on the horizon and the potential benefits of those and drawbacks and that type of thing. So I can kick it off here just in terms of just discussing some of the issues that might be a little bit more common knowledge or might not be for battery tech right now. So one of the main things, most batteries contain like the lithium ion style batteries. They contain cobalt, and the major issue with that is it's really only found in large quantities in places like Congo, like the Democratic Republic of Congo, and the mining process to get it out is brutal, and it's really hard on the environment and the people. So that's been one of the major criticisms of, basically greening up the automotive sector.
I can throw a good comment about the cobalt mining, because I was reading just generally about how the Congo's mining is horrible for people. And one of the interesting things that happens, especially with cobalt mining, because it's incredibly inefficient and difficult to do, is there's a lot of what they call artisan mining, which is a fancy word for basically going in with a pickaxe and digging it out yourself. And this effectively amounts to slave labor with how much money these people are making, but for a lot of them, it's the only way to survive. So companies won't buy cobalt from these artisan miners or anyone associated with them. So they basically end up selling at even a steeper discount to the official mining companies, who then launder this artisan cobalt and pretend that they mined it with their traditional methods. And then it gets sold. So there's almost no way to know whether or not your cobalt was mined by effectively slave labor or not.
Yeah, and if you look up pictures and whatnot of the cobalt mines, like I did, it's pretty awful. Like the safety is not a priority, to say the least.
Well, I mean, to be fair, like I think it's kind of like chicken and egg a little bit, where it's like part of the reason the methods are so scuffed for mining cobalt is just because it's all in the Congo.
Yeah, that's also true because, back in the day, mining it even in Canada was extremely dangerous. Like, it's still dangerous now. Like, I actually know of a fatality at a mine very recently here in Canada. Like, it happens, but, like back in the day in Canada and America, like, it just would have happened all the time. It's just like, well, whatever. It's just life. Move on. And
I just think, like, if half the world's deposits of cobalt were wound up being in Canada, I don't think cobalt mining would have a bad rap.
Yeah, that's true. So
it's just kind of luck of the draw of where the mineral was discovered.
Yeah,
or the majority of the mineral was discovered.
I would say that's definitely true. And as it develops there, you probably get a lot better safety. And as bigger companies come in who have reputations to keep intact, at least more so than other companies, they'll hopefully increase the safety and whatnot. But at the moment, it's pretty bad. Another one is like mining cobalt and some of these other precious minerals for these batteries actually is pretty rough on the environment in general. Like, you have to do big open pit mines, uses tons of water. So lithium, about a third of it or so comes from Argentina and Chile, in areas where they don't actually have a lot of water and they need to use tons of water in order to actually effectively mine out the lithium, because mining in general usually takes a lot of water for various functions. And so that places a lot of strain on these areas through draining their water reserves. So those are kind of on the beginning of the supply chain area, that where the batteries face some pretty big hurdles. There's also some some other ones that are in the actual batteries themselves. So at least from my understanding, you actually have to keep the batteries temperature regulated really well. If they overheat, they explode. And if they get too cold, they just stop. They lose a ton of their potential. So if you're, wanting to drive an EV around in a freezing area like Canada or parts of the United States, well, during the winter months, it's not nearly as effective and you can't go nearly as far. They also don't have a lot of discharge cycles. So typically, a lot of them are going to be around 1,000 mark, 1,000 cycles. So you charge and recharge 1,000 times, which at the end of the day,
yeah, 1,000 for EV is what I was seeing is the benchmark. Which, if you can't hit 1,000, your tech isn't ready for EVs.
Yeah, but even 1,000's that really isn't a
lot.
Well,
it depends on your range though, because some of this battery technology, it's not improving on cycles, but if you improve on the range, then all of a sudden 1,000 cycles becomes 800,000 kilometers. That's a pretty good lifespan.
That's true. Yeah, if you do have, but if you don't.
Well, I mean, but even the lower end ranges are still a lot of the times 200 to 300 miles, which is somewhere around 300 to 400 kilometers, right? So 1,000 cycles is still solid.
Yeah, it's still 400,000 kilometer long vehicle or so, which is way over what
motors internal combustions aren't usually going to hit 400,000 miles on there.
Well, and to be fair, the 1,000 cycles is not until the battery is like unusable. It's until the battery loses a certain percentage of charge, which it depends on what you're talking about. But a lot of the time, that threshold will be set at like 70 to 80%. So at the end of 1,000 cycles, you still might have like a very viable battery. It's just not
Yeah,
as
like if
good
you
as
had
it was.
1,000 kilometers of range after 1,000 cycles, you might have 750. It's a big deal if you're like talking 200, but it becomes less of a deal once again with more range, I think.
Well,
Yeah,
just
that's a
like
good point.
the beaters of the future will be electric vehicles that have like reduced range because they have low
Yeah.
batteries. But like it won't like it's not like they'll be inoperable. They'll just be kind of like gimped.
Well, and with all the electrification that's going on, or maybe the better word is digitization, putting computers into the vehicles, it seems like there'll be weak points that are more vulnerable than the batteries in terms of the lifespan for vehicles in the future. I think Tesla's already had some issues with hardware in their like tablets that run all their touchscreen stuff more so than they've had with batteries that I've heard of.
Yeah, that's a good point. Like there
are other
the
parts
weak
that'll fail
the weakest
faster.
link is like a lot of the concerns are overblown. And I mean you see that with hybrids. Like everyone was freaking out about hybrids being like completely unviable because oh no, the battery's going to give out and you're going to have to get a battery replacement after like 30,000 kilometers, and like many of the batteries have lasted like at the length of the vehicle.
Yeah.
All right. I got a couple more. And then you guys can jump in with any other ones that you have. A lot of these batteries are also, the chemicals are quite toxic. So once they kind of do hit their end of life, if you're just gonna throw them in a dump, they can leach out into the ground, especially if they're not. So if you don't take care of them properly once they're at end of life, you can wind up poisoning the environment, which is pretty bad. And then there's also just like, they're pretty heavy, so they cost a fair bit in order to just move around and transport. Like if you're shipping them to then have them installed in cars and whatnot, like that can actually wind up being a pretty big cost. And the other thing there is, as a point, like, or an aside on this, is they're like, for their weight and their volume, like they can be pretty inefficient, especially like if you're looking at like the actual energy capacity that they have for their weight compared to like something like gasoline, it's pretty low. So like a lot of the cars, a third of the weight is going to be taken up by the battery pack, and so that requires more energy to move. So again, like whereas something like gasoline isn't nearly as heavy for the amount of energy it's going to output. So it's one of those challenges where, if you want to get everything more efficient and basically green up your systems, that's a big hurdle to overcome. And then one of the other ones that I came across is like, just basically a lot of this stuff are like a lot of the components can be pretty expensive in general, and so it's just cost prohibitive for the average person to, like, install battery banks in their house or buy an EV, because the price is elevated just due to the material inputs. That's all I had for now. So if you guys got a couple more that you want to toss in there, go ahead.
I think one that should come up, because it really seems to inhibit research and development from becoming practice, is the volatility of a lot of the chemicals that are being used to make these batteries. Fires are always a huge concern, and one of the easy ways that they do have to deal with that fires can happen is just dendrites being caused, which are basically a metal spear from one part of your battery to the other part that stabs through it and causes a short circuit and lights it on fire. And that was what was happening with, say, Samsung's batteries and their famous phones that would constantly light on fire. But that can usually be solved in the lab with charge-discharge cycles and figuring out how to mitigate it. And then the one that happens with EVs all the time that seems very difficult is the crash testing. to make sure that it's safe in a crash and it's not just going to explode and kill the driver. So they have to do puncture tests and stuff along those lines to simulate an accident. Obviously, there's within limits because a regular vehicle can explode and kill the driver, but they don't want you to get like a nail through the bottom of your car somehow and have it blow up. So that seems to have been a really difficult thing to overcome, is all the actual practical safety aspects of developing battery technology.
I just add in something there as well. It's like a lot of that stuff then also makes the battery packs heavier, adds to the weight.
Yeah, the safety.
Yeah, and like you said, like cost and all that, but it just is a pretty big increase in your cost and your weight, and your therefore lack of like lowers the efficiency.
Well, for instance, solid state battery, which is something that people have been working on for a long time to overcome lithium ion, was actually fully developed in the 1980s as a concept, and then when they rolled it out, it started randomly lighting on fire, and they had to recall it, and the company went bankrupt from the liability. It's like they just couldn't get the safety done.
Anything else, Hubbards?
No, not. I think you guys got most of the points, the generic concerns.
All right, so let's just move into some of the upcoming technologies that are hopefully showing some promise. Price, do you got one? Because I saw you had
I think
good number of them there.
Yeah, the thing that we already see, like right as of this year, I think about 2021, it started actually being manufactured, is the cobaltless lithium-ion batteries. And basically the maneuver there is to reduce the amount of cobalt because it's the most expensive commodity that's actually put into a lithium-ion battery. And CATL, which is the biggest battery manufacturer in China, has been selling lithium ion without cobalt to Tesla for their Chinese Teslas, as far as I understand it.
Yeah, I think it's called iron phosphate instead. It is definitely phosphate, but I don't remember if it's iron phosphate. But yes, that they switched over to that. And I think Tesla has indicated...
I don't think it's iron. I think it's like a nickel magnesium phosphate or something.
Oh, is it?
But
Tesla does use in China only lithium iron phosphate LFP technology for their batteries.
That's what it is. Yeah, because I know that there's the magnesium one as well, but I couldn't remember which one.
Or manganese. I don't know. Anyway, removing the cobalt is something that a lot of different companies are working on various solutions to, and CATL has one that's in use, obviously.
I can't recall, but I thought Tesla was also going to eventually switch over to, like, for all of their non-long range ones, they were going to start using those batteries at some point.
I think that, yes, that's been Musk's direction or planning, is for your standard models, they're going to be using the LFP technology or other non-cobalt technologies. And it basically, because the chemistry dictates the density, and LFP is about half as dense as cobalt chemistries in terms of energy density. So it just makes sense. It's cheaper and less density, so it just makes sense to put it in your low range, premium products that are, or low margin products that are just like the Model 3 and stuff like that are not going to require the performance and distance that their higher end ones do. And those were, as far as I know, he's stated that those will remain with cobalt chemistries for the foreseeable future.
I know they've also been doing work to reduce the percentage of cobalt required in the batteries that do still use cobalt as well.
Yeah, because there's a lot of different configurations of cobalt, with like different proportions of the various materials. And yeah, the Tesla's been trying to push down the cobalt as much as possible, even on their cobalt chemistries, but it's yeah, it's just seems to be very useful in keeping things stable, which addresses a lot of the points that batteries need for to be put into vehicles, because like cobalt makes them higher density, which is obviously really good for because you reduce the weight needed and you just reduce the range for the same amount of weight, et cetera, et cetera. But also increases the stability for safety, much less likely to cause fires when you have cobalt in your chemistry, which again, obviously is going to help for the auto industry. Like, I think that's why like cobalt has been such a stubborn, persistent material in especially EV batteries, because it just brings everything to the table that you'd want for EVs specifically. Like that's the other thing Musk said, is they're going to go cobalt free on their like fixed storage battery banks. Which, why wouldn't you? It's not really the same. It's not the same space, weight, density, safety concerns for those types of applications, and therefore just really like the performance EVs where you can't really get away from it. It seems at this point in time.
Is that what we've got on cobalt?
Yeah, I don't have much more on
I
that.
just have a couple other, like, because there is some other chemistries being developed that are not LFP but are cobalt free, and
Okay.
I don't know. I could just briefly touch on them. Like a couple of I saw were like there's a nickel iron aluminum chemistry. There's also a nickel manganese aluminum chemistry. So it sounds like the projections going forward in time basically predict that there'll be a mix of LFP and then cobalt batteries, and then other alternative non-cobalt chemistries. So that those are going to be like your general three big players in the EV battery market. Is going to be cobalt based chemistry, LFP, and then these like new developing non-cobalt chemistries, like such as like the nickel iron aluminum stuff. That's what most people see as the three big players in the future.
If you want to get technical about this, it's not very necessary to remember the term, but that is all of the chemistries that make up the cathode of the battery. And then the other part of the battery is the electrolyte, and the electrolyte conveys between the cathode and the anode. And if you're wondering where the lithium comes into play, it's almost always in the anode, although there are some cathodes under development there might be cathodes in production. I didn't look deeply into it. They use lithium as well, but it's the big use of lithium is in the anode, and that doesn't really seem to be going anywhere for the next 10 to 15 years.
Well, and I also have just like the numbers on like where the costs come in is also why you see so much more talk about like the cathode materials in cobalt is 51% of a typical battery cell. 51% of the cost is the cathode. So, and 12% is the anode. So it's like, yeah, lithium matters, and like anodes, I'm sure there's development, but like the big push is to figure out alternatives for the cathode, because it is the cost driver for batteries, and everything else is kind of like you can pick up percentages here and there, but not nearly as important as getting the cathode costing and material sourcing correct.
So one of the big reasons they do research the anodes, though, which obviously isn't the cost, is to reduce the size. Which, if we could we want to transition into that, that's the sort of semi-solid state battery section. I'm not sure if you had more to say. Sorry.
No, I think that's a good transition point into that.
Because what they do with the anode that takes up quite a bit of space is they embed the lithium ion into a graphite sort of matrix, so that it's much larger than the actual amount of lithium that's doing the work, just in order to hold it and stabilize it, and hopefully prevent some of those dendrites. And the technology that's come along this year actually is the first time it's been manufactured on a mass scale, and has been sort of under the radar before that, as far as I could tell. Is semi-solid is what they're calling it, and it's a sort of flow battery. And instead of having, I'm not quite sure why it's called semi-solid, because instead of having a cathode and an anode that are solid and electrolyte that's liquid between them, like a lithium-ion battery, they dissolve the cathode in the electrolyte and they dissolve the anode in the electrolyte, and then they have them meet through a permeable barrier where they can exchange their charge. So unless I'm missing something drastically, it's actually more liquid than lithium-ion batteries. But this is a big breakthrough in that it offers almost double the energy storage per weight that you can get with lithium-ion, because one of the reasons being because it doesn't need that graphite matrix to hold the lithium ions, and it can actually use lithium metal. Although one of the drawbacks to this technology is that the lithium metal has to be exceptionally pure as opposed to a lithium-ion battery. But both Volkswagen and NIO being a Chinese EV company, have stated that they have this technology being mass produced for them. And once it gets into their vehicles, they'll have vehicles with 1,000 kilometers of range off of their battery. So it's quite a jump in terms of capacity. And the technology is not very different than typical lithium-ion technology.
Boomers in shambles.
Basically. Well, and
Boomers
also
in shambles, absolutely blown out.
Potentially everyone working on solid states in shambles, because if this really catches on, it'll be very hard to uproot, because it's going to be so effective. Like 1,000-kilometer range on an EV is kind of, that'd be like the meme thing. Oh, I'll buy an EV once it can go 1,000 kilometers. Well, now it can.
Yeah, and what are your uncles going to say about against EVs?
Yeah,
it's like, oh, I just can't.
You're just gonna call them gay and
take
move on.
Can't take a 20-minute break to charge. I need to get gassed up in 3 minutes. It's like, oh, well, you can go 1,000 kilometers. Do you not take a 20-minute break every 1,000 kilometers? No, I really don't. I drive 16 hours. Don't even gas up. I just have a can of gas stuck in. I have an extra couple of cans of gas stuck in the gas. And I just give her
just a jerry can.
I got a couple of jerry cans.
And duct tape to the.
I hang out my window and I fill it up, and I just keep going.
Thank God they put that autopilot in all the trucks these days.
Once the gas is empty, I fill it up with piss and just rip.
I'm so drunk that my piss is pretty much alcohol, so it's good to go.
I got some ethanol for later in case I run low. But that's like the classic, the last holdout of the EV haters. Just like, what if I did 1,000-kilometer trip?
Comment there though, like, is it going to function in low temperatures? Like, how much would it?
Well, nothing actually functions in low temperatures. That's what I've also learned doing this research. Most lithium ions don't function below 0 degrees, so they have to. Like, the reason they lose so much of their power in cold weather is because they have to spend a lot of their electricity heating themselves. And it seems to not be a problem that anybody's close to solving. Some of the solid state technology is getting to like -20, where it can operate perfectly fine, like negative 20 Celsius. But that's the coldest I've seen for standard operating temperature. And anything under that, you're losing efficiency.
Well, I'm just wondering, because they have to heat up their own battery, right? So if you have 1,000 range model, that you might only, you lose 200 kilometers and you still have 800 to go. So you might be fine. But I'm not
keeping
too sure
it running
how
in the winter,
works, right?
The technology would be slightly different than lithium ion. And as I was saying, because it's more liquid, I imagine it would be slightly worse in cold weather, but that's just complete postulation.
Yeah, like that would be like, one boomer criticism that actually would still hold, right? Where it's like, okay, if you're losing a huge chunk of your available range in cold temperatures, which tons of people live in,
tons of people, really? Like a couple million, let's be honest.
Well, we're talking like Canada, it's not a lot population wise, but a lot
of look at Scandinavia. Scandinavia is like
a lot of the states gets pretty damn cold when it's the winter time. Like
maybe for a month. Like,
Well, I don't know if you guys actually looked at the numbers for how much range you lose, but maybe it's just Tesla propaganda. But when I was like looking into it, I saw like estimates of it, like if it's like below, if it's like freezing, if like winter weather in Canada, you're looking at like 20% loss,
I
essentially.
think I saw numbers similar to that, like 20 to
Yeah,
30%.
and that's what I was saying. Like if you had a 1,000 range vehicle and you lost 20, maybe 25%, like it probably still wouldn't be that big of a deal. But like I just want to, put up some devil's advocate for the boomers.
For the
Despite
boom, well, I mean,
gotta steel man
again,
them here.
Well,
yeah,
I saw a Ford Lightning up north, so I think it's over. The boomers have capitulated because only a boomer could afford a Ford Lightning.
true. Or it's a
Rig pig.
Zoomer driving it, but a boomer bought it.
Oh, yeah, that's the textbook, the play. Or
another
a
option.
zoomer with the boomer's money because the boomer ate it because all he did was smoke cigarettes and drink until he was 50 and died.
True, but yeah, I don't know that. I think even with the cold weather penalty, once you get up to 1,000 kilometers in
Yeah,
range,
like
it starts to be really hard to justify
exactly. That
like
but I
use
just wanted to
cases
know, like, if
where.
it was gonna be losing like 50-60% of its efficiency, like then that'd be
Well, I mean, that's
that'd be
still on the
rough.
table because they don't say anything about cold weather performance because 95% of people don't care. It's like,
Well,
it's just not
95%
something
people
that's
don't
ever
buy.
really come up in any of the articles that I looked at.
Yeah, they.
Other
Well,
than
in some of the
how
ones that I
cold it
found.
could go. Like, it was impressive when the one could go negative 20. That was the one time I saw it mentioned.
Well, the other interesting thing to think about that is, I wonder for long trips if you're actually getting less loss because you're like not having to heat up and cool down and heat up and cool down again. Because like I know a lot of the range losses estimates from cold weather would be in like city driving conditions where you're driving 20 kilometers at a time and you're letting your battery cool down and then starting it again, right? And
yeah,
the
actually, because as you run or discharge your battery, you're giving off heat for sure. So you're not going to have the same issues once you're actually in motion, say on the highway. One of the big things I did see was a lot of the concerns tend to be with overheating batteries.
That's like
that's one thing people run into when they try to make them practically useful as well, is that in real world conditions they'll overheat. Yeah.
Yeah, so it's like, okay, losing efficiency or blowing up your car. One is definitely worse than the other.
Well, and I can imagine, yeah, if you're doing a road trip in, Nevada or whatever, and it's 45 degrees outside, that could make it hard to like adequately cool the batteries. I don't know. I'm not.
Yeah, that's where solid state seems to have a big edge, is they don't need to work out how to keep it cool, because that also, depending on how you do your cooling, but it seems like that can take up space in your battery pack, is giving it room to cool, or like thermal channels.
Well, I mean, that brings up another good point, is like you were saying that maybe solid state is too late, or like not necessarily gonna get to market on time. But I do think like there's other benefits of solid state that will make sure that it keeps getting worked on at the very least.
Yeah, for sure.
It's so much. It has like the cooling issues, and that wraps around with the safety issues, where it's way more stable and way less likely to light on fire in like accidents or whatever. So that just makes it incredibly attractive for EVs in particular. The other thing, I don't know if either of you looked at it or saw anything about discussions about it, especially for the new tech you're talking about, their price, but charge rates. Like, I know that's one of the attractions of solid state is faster charge rates. So you can imagine if solid states are the same as this liquid one, but in terms of density, but one charges, twice as fast, that'd be a huge selling point. So
I think that's probably a good estimate from what I've seen, because this liquid sort of semi-solid battery, as they call it, it's supposed to charge and discharge at a higher rate than a traditional lithium ion, but I didn't see any claims that it would be competing with solid state. Like solid state, once they figure it out, like in the lab, it can be a lot faster discharge and charge than lithium ion or this semi-solid lithium.
Well, my other understanding too is also like we were talking earlier about like cycles. That's solid state have like way more cycles if it's done correctly.
There's a lot of development that needs to be done on that, from what I could tell, because it seems like a lot of problems with solid states in the R&D are coming from not being able to hit the charge cycles. And I think what's happening there, at least in some cases, is that they're still getting dendrites in a similar way to lithium ion. But what happens with the solid states is that the electrolyte is not liquid, but solid, and that reduces the size of your battery. But it also means that if you get dendrites that stab through that electrolyte, that they don't have to grow as much to stab through and cause a short circuit and a fire, which is what the Canadian company in the 1980s ran into, was just by charge-recharge cycles, discharge-charge cycles, it would light on fire with no external problems. So theoretically, I think there's a way higher ceiling of charge-discharge cycles that can be achieved if you had a perfect solid-state battery. But right now, it's still a big issue getting the charge-discharge cycles up to 1,000. Like that's one of the difficulties they're running into.
Okay, so in practice, that's actually performing worse in terms of charge cycles than current technology, more or less.
Yeah, it's one of the things that a lot of people have had hang-ups with, it seems like. Like one of the most developed ones that I could see information for charge-discharge cycles had got to 400 charge-discharge cycles before hitting 80%, which is still under like 1,000, as we're talking about, is usually what a current lithium-ion battery in an EV will get before reaching around 80%. So they only have to get 2.5 times better at it.
Though, to be honest, like the advances in the traditional lithium ion batteries in the last like decade have been pretty crazy. So it's not like
that's
impossible.
The solid state stuff in terms of practical testing, it seems to get twice as good every 2 years. Like when you look at the companies that are still making it, like they started off with very modest practical achievements, and they've scaled them up to being imminent for use in the ones that talk about it. And then Toyota actually has a solid state that's on the road being tested, but they don't give out nearly as much information as some of these other companies. I think because they're not as they don't need the shareholder investment that the other companies do. They're mostly self-funded and working with Panasonic.
Although I do find it interesting, like of all the car companies that I've looked at, Toyota is like the least bullish on electric of all the companies that I looked at, which
the only other one that seemed I would describe them as not being bullish was actually CATL. Like the battery manufacturer in China basically told the Chinese Securities and Exchange Commission, or whatever they call it there, when applying to expand their business, because they have to demonstrate that they're not causing undue risk to investors, that by 2030, they figured 1% of the battery market would be solid state, and that it wouldn't really hit its stride until 2035. And they have solid state under development. They have this semi-solid state, and they're still not bullish on the time to actually develop it and get it into vehicles. They think it'll be quite a while.
I guess I was saying like Toyota on electric in general, not just solid state, but on everything electric, they're like the only hesitant automaker that I've seen. Every other company is announcing, like 50 billion investment here, and we're going to be 100% EV by 2035, or we're not going to sell an ICE vehicle after such and such date, blah blah blah. And Toyota like just as recently as like last week, their CEO was like pumping the brakes repeatedly on EV and saying that it's not practical to go full EV and the timelines aren't realistic. And I don't know if that's just like Toyota's more cautious about their PR, or if they are just, they feel like, I don't know, like to me it's just hard to figure out why they're the odd man out, I guess, so to speak.
I could also see it being like the Western auto manufacturers just really trying to suck up like good PR, right? You know, just promise the moon and then not deliver, and like, oh well, we missed that. Oops. You know,
Everyone just wants to be the next Tesla.
Yeah, exactly. Like they're all throwing, like, talking a big game, but like they might not be. You know, this is just complete conjecture on my part, but it could be that they're looking to garner some good PR for themselves, make themselves look green, all of that, when they don't really have a proper plan in place, or might not even understand like what they're actually like the challenges that face them. And maybe Toyota is kind of being a bit more honest about things, because they have been running the hybrid scheme for a long time, whereas
I think there's two
automakers haven't at all. Like
there's two things with Toyotas. Obviously they love hybrids, right? And then they actually just developed a new nickel metal hydride battery that's more efficient, about twice as efficient as old ones. And I didn't realize this, but nickel metal hydride is still currently what they use in most of their hybrids. So it's going to make their hybrids either have larger battery capacities or lighter weight, depending on how they decide to apply it. But I think obviously they come out and talk about their hybrid plan and how that's what they're focused on, which is one reason they don't like EVs. And the other one is that they've been invested so much into solid state, and they have the vehicle out there on the road. And they've basically said the problems they've found with operating a solid state vehicle mean that they don't think they'll have solid state battery electric vehicles, like a full electric, until probably around 2030, but they'll have solid state hybrids by 2025. So that lines up with Cattle's idea about when solid state will become viable. I think Toyota unwisely basically wrote off lithium ion as insufficient for the job of battery electric vehicles. So they're kind of playing catch up in that frontier. And I think they still believe the solid state battery is required to actually fully transition to electrics.
Yeah, I mean, that's possible, but they're still talking about hydrogen fuel cell, and they're like still have a hydrogen fuel cell for sale.
Well, I think that ties into I think they still don't buy into lithium ion. Like they still think that, as it said, they still think hydrogen is up there as a big option, big potential in hydrogen. But the only guys that see it.
Yeah, I guess that's why I find it so interesting, is that they're the only ones that see it, presumably. Like no one else talks about hydrogen fuel cell. Nobody else.
Other companies work on it, but it's never a focus, whereas Toyota's been trumpeting it for like 5 years.
Yeah, exactly. Like the messaging from Toyota is like very different than every other company. And to be honest, like they could easily, you know, throw their hat in the ring if it's just for PR, right? Like there's nothing preventing them from taking the same route as every other company and just saying, oh yeah, we love electric, we're going to get lots of electrics on the road, and then failing to deliver anyway. Like, I don't know. It's just,
although there's a few people who think that the only reason they're coming out with full battery electrics with lithium ion is shareholder pressure and PR. Like there's a couple articles I read on Toyota that thought they basically didn't want to do it ever. Like they didn't ever want to have a full battery electric, and they're going to have 5 out by 2025, I believe. Or no, 15 models. Although I guess that's probably just like 3 cars with 5 trims or something. But they're going to do it. I think they're doing it as soon as next year for their first all electric
Well, they already have an all electric on the road.
in Europe only, right?
No, in Canada.
Oh,
It's
in Canada? I thought it was
the
2023.
SUV. I can't remember what it's called. The B. It's on sale on their site. You can't get one because there's like probably 500 made for Canada, 300 made for Canada. But they're
I must
apparently
be a
they're
year
giant
behind.
they're a giant piece of shit anyway. That being said, like I do think it's interesting that they've talked a lot about transitioning their Lexus line over to full electric, and I think that goes back to like what we're talking about with cost. Like the electrics are definitely expensive, and if you look at the companies that tout like, oh, we're going full electric by such and such date, well, the only models that have really been brought to market by and large are premium products. Like, and I don't think that's a coincidence. I think it's they bring, like, say like the Ford Lightning, right?
Yeah.
It's all about bringing a super high cost or a super high selling price product that they can still make margin on, because electric vehicles are so expensive to make. So you can't sell a Corolla at a markup and keep it reasonable priced and have it be electric. It's just not possible.
The one company that's on that, like the real electric grind, I remember looking pretty deep into electric vehicles at one point, seems to be Nissan. Like they genuinely offer your best bang for buck kind of electric vehicles and have a really good reputation.
They have the Leaf, which is like reasonably affordable for an all electric car.
Yeah, there's the Leaf, the Bolt, and the Volt in North America. That's like your three electric options that aren't a complete
luxury vehicle,
or like a complete fleecing, like a complete luxury. Yeah, because like, I mean, to me the pinnacle of like electric excess is the electric Hummer. I don't know if you've seen reviews. So it's something like 7,000 pounds, or like it's one of the heaviest vehicles on the road. It's like an actual tank. It's as wide as two regular vehicles, and it's just, I don't know. It's
doesn't have double the battery capacity as like a Model 3. It's just enormous.
It has well over 100 kilowatt hour battery. Like, yeah, it's just. But again, like it goes back to just like the battery cost being at this point in time so high that the only reasonable, I guess, from a business perspective, vehicles to offer in full electric are premium models that customers don't care if you're charging $100,000, which again, like that's been Tesla's success, right? Is managing to sell, I don't know what, their average price of a car is, but it's going to be way higher than any other traditional.
I think in the US it was something around 35,000, which was a whole margin higher than cars that sold equivalent numbers. It was crazy.
No, but the average price of a Tesla is not 35. It's got to be like something like 70. The cheapest they offer is like 35.
Yeah, that's that is the Model 3. It comes in at the cheapest at 35, and Musk has plans for 25.
Okay, but I think I'm only thinking of the Model 3, but the Model 3 is competing with like the Honda Civic and the Toyota Corolla in terms of sale numbers at one point.
Well, I guess what I was referring to is like the average selling price of Tesla, a Tesla vehicle compared to other brands has to be astronomical, right? Like, if you compare
like their lineup.
Honda's average transaction price for a vehicle versus Tesla's has to be tens of thousands of dollars higher. And again, it's because they're going the full electric route, meaning that the only business model that works is selling cars at a very high price at this point, because batteries, again, like if you look at the numbers, and this might have changed a little bit, but the numbers show that for an electric vehicle, the batteries themselves is about a third of the total cost, which is, that's huge. And like right now, I only found numbers from 2021, but a battery per kilowatt hour is right now is for the battery pack. So I mean, we can get into the terminology. There's lots of terminology, but for like a finished battery pack right now, in 2021 the price was about $131 per kilowatt hour, which apparently this is all the industry experts say that the magic number is $100 per kilowatt hour. Getting it under that is where you kind of get cost competitive with traditional internal combustion engine vehicles.
Yeah, I think I've seen that as well. The $100 is almost too nice for me to fully buy it, though. It's like I feel like half of them just chose that number because it's 100.
Yeah, well, a lot of that type of estimation stuff is just a little
Well,
bit of fantasy.
30% of 30% is like 10%. So if you drop that, it'd drop like 10 or 12% or so off of current electric vehicle prices, which seems like they would still be high. But I have no idea what actually goes down into pricing a vehicle. Maybe there's some way that it works out.
Well, I think you can speculate, but that's the cost, right? So your pricing doesn't necessarily always just one-to-one with the cost.
Yeah.
And that being said, it is probably just an estimate ballpark. But again, if you're even if you take it as an estimate ballpark, if one of your major components is 30% higher than what it needs to be competitive with another product,
Yeah.
not a very viable business model at that point in time. So I think that is like at this point the main battery problem is cost. And from what I've seen, I mean, like there's all the different chemistries that we talked about and the different, cobalt being involved with all its problems, but I feel like those things are getting worked out, and the cost is the biggest hurdle, and that is slowly coming down. And I think like we see like pie in the sky articles about battery technology every other week, but the thing that does seem to keep happening is innovation in every which direction, and then all of those things have been competing against each other to bring costs down. Like if solid state doesn't work out, then it's not the end of the world because something else was already in parallel development.
Yeah, that's one of the things I definitely noticed is there's so many different techs and so many different, like, even just kind of similar type of batteries, all sorts of different chemicals that they swap out for each other, but just also different, like, because the basic premise of a battery, basically you have your anode, your cathode, your electrolyte, and then you just have a way to like a membrane, and then like that principle doesn't really change, and so you can figure out many different ways of doing it. So like when I would Google it and start going through their articles, there were just like every like 3 months there's a new article of a new type of technology that looks promising. A lot of them I think wither on the vine, just because like the major thing that I noticed is it's one thing to develop a prototype, and then it's another thing to actually get the whole industry rolling on it, like building out your entire supply chain, pumping out tons of batteries, that type of stuff. Like
I have a good example on that, because there was a company that was doing a lithium metal anode, which, as I said, makes your battery smaller, and it removes unnecessary graphite, or like if you can do it, it now renders the graphite unnecessary. And they were actually selling production batteries to drone companies, but they hadn't figured out how to really avoid the dendrite problems yet. So they're only getting 50 to 100 cycles. And they just basically went under because investors figured they wouldn't improve that technology. And even though they were making sales, it wasn't a big enough market to matter. It's pretty cutthroat in the battery business. If people don't think you've got it, they just pull all their money and give it to somebody else.
But it does mean that like the tech is still there, and the patents are still there, and the ideas are still there. So somebody else comes along with a clever way of figuring it out, like you can then have further developments on it.
Mm-hmm.
Well, and to be honest, like I guess like before looking into batteries, I was more pessimistic about batteries, but it just seems like you guys were saying, like the fact that there's a whole different slew of options gives me optimism in the fact that like if one particular commodity becomes impossible to source or unavailable or cost prohibitive or whatever, there's 5 other technologies already ready to take off, and I don't see anyone, like there's no Achilles heel. I don't, from what I can tell of like battery, batteries continuing the march to become cheaper and more accessible and in everything. And I guess like one other interesting thing about that is batteries are really recyclable too, which helps.
Mm-hmm.
I mean, the recycling process is not exactly the most environmentally friendly because you get byproducts and a lot of energy use and whatever, but you can recover like in the high 90s% of a lot of the minerals that go into a lithium ion battery, no matter what the chemistry. So once you pull it out of the ground, it's not like end of life EVs are just going to be, hurled into the landfill and leach out into the environment. That
There are,
people
like
are going
from
to
what I was
recover
looking
them.
at though, like we don't have, like there hasn't been like a big setup for recycling as much as needed, especially since like the batteries are new. But I'm sure that will
That's a big
come along
thing.
as like the batteries now start to, because like there really
There's
hasn't been
already
a ton.
companies that are doing it, like they have like big factories, not to the scale that will be needed, but there's
Yeah, but
already
it's
companies
starting, right? So like
that
the
do
groundwork is being laid.
there's already companies that recycle, I don't know, thousands of metric tons of lithium ions already. So it's very doable, and it's not like there's a technological impediment or anything. It can be done. I think a lot of that is just going to be like legislation that requires you to recycle is like the only thing that actually would stop that's like the only roadblock is if governments don't bring in legislation, people might just find it cheaper to throw it away. But as long as they're required to recycle, there's the technology there ready made, and it's not that hard. I mean, you'd have to factor it in to the cost of owning or whatever a vehicle, but or
Also
battery
depends
stuff.
on commodity prices, because obviously the higher commodity prices get, the more viable recycling becomes.
Yeah, exactly. So it's kind of a self-correcting problem in a certain sense, right? If batteries are like going absolute nuts because there's a huge demand for them, well, then there's also a huge demand for all their input components, which means there's a huge demand to recycle them. So it's kind of like the recycling will spin up in proportion to the amount of batteries being, produced.
Yeah, especially as
Yeah.
like it might become harder and harder to access certain material components.
Well, as if you make an analogy with oil and gas, which might not be fair, but obviously the easiest access deposits are what people access first, and they're the cheapest. And then as you start mining things out, then you get into more and more expensive to access deposits. And if that's similar at all to any of the commodities involved in batteries, then that also, the more you use, the more difficult it becomes to extract from the earth, the more viable recycling becomes.
Yeah, I think at least when I was looking into cobalt, that's true. Like obviously like you'll hit certain really productive veins, and then you use them up the quickest, and then you have to go for scraps essentially, right, in whatever geographic area you're digging out. So I would imagine that many of the commodities are in the same situation. So that's true.
One thing that I thought was interesting is looking into this, I looked into a lot of individual companies and news releases on them to try and figure out what was going on in sort of the zeitgeist of the battery technology. And it seems like a ton of companies, but I couldn't see any forecasts other than a shortfall of battery production in the next 10 years. Like the demand for batteries is forecast to just be incredible.
Yeah.
And it's almost, I didn't see a forecast that thought we could possibly keep up with it. So there's going to be a lot of room for these different technologies to all sort of share the field, as there's this massive demand and not enough supply. And then presumably as supply increases, it'll whittle it down to the best competitors.
Yeah, that's what I saw as well, just because there's obviously constraints on the various inputs, and as it's good to have that competition because we are like limited in many different types of the inputs. So having all of that will actually alleviate a lot of it. Is there any other battery types that you guys wanted to cover?
I would go a little bit more specific in the solid state.
Yeah, I think
In that one of the most
that's a big one.
promising technologies, and this is probably long term, like you wouldn't see this until the 2030s. But I believe his first name is John, but his last name is Good Enough.
I
And
know.
that's how you know.
I love that. It's
So you know this
literally
guy
good enough.
gets it done. And he just got a Nobel Prize in 2019 for being one of the most influential people in developing the lithium-ion battery. And he worked on a project to develop a solid-state battery. And this solid-state battery used a glass electrolyte as opposed to a liquid, or what a lot of companies are trying to use is polymer. So this glass is, as far as I can understand it, the groundbreaking aspect of this particular technology. And it allows the anode to be sodium instead of lithium. And obviously sodium is just a part of salt, so easily accessible. And the company that I could find, the only company that I could find that is putting his technology into practice, was good old Hydro-Quebec. And Hydro-Quebec is partnered with Mercedes-Benz in developing this technology. So that's a long-term one, but it's pretty neat that you never think of Hydro-Quebec ever. And apparently they're a player in the
Speak for
solid-state
yourself, sir.
Yeah, it's like good old provincial company making gains. I assume it's provincially owned since it has Quebec in the name. It's like you wouldn't have expected it, but they're out there. They're big players right now, theoretically.
I think
That is
yeah,
rather
that's all for me in terms of the various technologies and problems.
Yeah, that's it for me as well. Unless Price, you got anything more? I think we can go into wrap up.
Yeah, we might as well wrap up, I think.
Yeah, so what are your guys' thoughts on just, like, I guess, general implications, and then maybe some more implications and forward looking for the average person, average consumer, and even yourselves?
Yeah, I think for me, it's like battery technology is like, and battery technology and cost is like dropping like a rock. Like I did look into home battery storage because I was thinking like with battery prices declining so much that home battery storage might actually be like reasonably priced. And it seems like for right now, for what you pay for what you get is not great. But I will imagine in like 5 to 10 years, you're going to get a lot better. Like things are going to get much cheaper and much better in the next 5 to 10 years.
And it can be viable financially right now if you have the ability to arbitrage your electricity. So some American states, for instance, you can buy electricity at night when it's cheap and then sell it during peak hours back to the grid and make the cost that way.
It's also viable if you just have like a poor like quality electric grid or no electric grid. Like if you're living off the grid, like you can get like a acceptable system for like $10,000.
Yeah.
USD, I guess. I don't know. Canada would be pretty similar. So, I mean, that's still expensive, but if if that means you have power at night in an off the grid living situation, that's not that bad, honestly. Like if you're on solar during the day and you have enough that you store it at night, like you can get 10 to 20 kilowatt hour storage, which would be enough to get you through the night for sure and have power during the night. But like I said, I think for me, the takeaway was like cars especially are going to get a lot better. Electric cars. I think I think if you buy into a car right now, like a fully electric car right now, I don't know how well they're going to age personally, but I don't know. That's just kind of what I think. I think it's kind of like too early, in my opinion, to pull the trigger. Unless, I guess the one caveat I put there is unless you like get big fat government incentives, this might actually be a decent time to go with it if you do, because those won't be around forever, and it definitely helps. But if you don't have any government incentive, then I don't know. It just seems like keep your gas vehicle and just run it till it explodes in 5 years, and then get electric. It'll be a better car by miles by then.
Well, I can agree with that last statement. If you have a gas vehicle that'll drive for 5 years, there's no reason to buy an electric right now. But I would say that after researching this, if I was looking into electric, I'd be comfortable to. If I needed a new vehicle, I'd be comfortable getting electric right now, because as far as I can tell, in my mind, solid state was always kind of on the horizon because Toyota said they'd have it by 2025, but it seems like that's only going to be for hybrids. And it sounds like solid state in terms of mainstream won't really hit until the 2030s. And the lithium ions do everything that the vast majority of people want. Like I would want a car with 400 kilometers of range, and you can get that right now, and it'll last you 1,000 cycles. Like that seems perfectly serviceable to me for anything I could imagine myself doing. But that's only in the circumstance of buying a new vehicle outright and considering government subsidies, which in Canada are about $8,000, which that pretty much makes the difference. If you didn't get that $8,000 off, I think it would still be a little bit unaffordable. It's still on the higher end, but it's not. I don't think it's unreasonable at all to buy an electric right now.
Well, I would say though, if you look into it in Canada, the threshold for getting those subsidies is like 50,000. So anything over 50 is like I think it's 50. It's around there.
You got to look specifically by the company that's selling it, because Tesla managed to do some boondoggle thing where their MSRP is over 50, but they still get the full 8,000 off. So it's like the company has to apply to the government to like demonstrate that they deserve. So the government actually says that's the 50,000 margin, but I believe that it's based on models, and you can look up what your model gets off.
Yeah, exactly. So you do have to be careful, I guess, is what I'm saying. Like you can't it's not across the board electrics in Canada, and same with the US. I think there's different state, and that's also it varies by state and province on which gets what, because like some of the rebates in Canada are provincial, and most of it is federal, but some of it's provincial. So you have to like check also that the provincial is the same, blah blah blah. And I guess what I'd say is like right now, even if you're buying a new vehicle, I would say it's just like for the average person, you're just better off buying a internal combustion, like,
or a hybrid.
You're probably paying, an internal combustion primary vehicle, right? Like a hybrid, right? Hybrids don't get any power from their electricity. Like you don't charge your hybrid unless it's a plug-in, right? Because you're paying like, I don't even know, but it's got to be at least $10,000 to $20,000 more, even with the government subsidy for equivalently the same vehicle.
Yeah, I'd say about 15,000 would be about your average markup.
And that's like MSRP, which you can't get electric vehicles at MSRP these days. So it's just like, you're never going to save that in gas. It's just not viable. And
man, you're just not seeing the $200 barrels of gas coming. You got to believe.
Yeah, even at $2.50 a liter, I don't think you're saving you're saving money over the lifetime of the vehicle. So, like I said,
No,
I
you
think
actually do save ridiculous amounts on electrics if you charge at home. Like if you charge at home, you'll save, I think it's something like $50 a charge versus gassing up. Like it adds up quite quick. When I did the math, it made sense financially if you were going to drive, I believe, 250,000 kilometers, something like that.
Which is pretty.
Although I guess
reasonable for the life of
you
the
might
car.
not drive as much because you might be avoiding big road trips. So you have to be realistic about how much you drive. But you can do the math, but it can add up that you make that $15,000 back. Depends what you're comparing it to as well. Because I'm comparing it with SUVs, which aren't as fuel efficient as cars. Obviously, like a 3-cylinder car or like a Chevy Cruze with a diesel. Is it a Cruze? Those things are crazy fuel efficient, and then that also changes your calculation a lot.
that's true. Like, again, like I still think, all things considered, I think it's just sizably cheaper to buy internal combustion right now. And like the thing is, like, yeah, like in 5 years you can always pick up an electric, and it'll, like if the circumstance changes, I think everything's pointing towards you having more options and better options on electric in the future. So like delaying your purchase of an electric, I think is nothing but like beneficial in my opinion. Like there's just, I think we're still kind of in like the early adopters phase where you're just paying for the novelty and coolness of having an electric by and large, unless like excluding a handful of specific circumstances, you're paying a premium for the cool factor. And like obviously Tesla capitalizes on that hard, right? Like they sell a very expensive vehicle. Like if you talk about SUVs, like a Model X is like $100,000 in Canada. So it's just not even close. Like it's just,
I can also fully agree with the cool factor aspect. I'm just going to say that for most people, cool factor comes into buying their cars. Like you don't see a lot of people in the Corolla or the Civics. Like they are the most popular vehicles, but it's like most people want to buy something fancier.
I guess like you just go into it eyes wide open, right? Like if you're willing to spend an extra 30% because it's electric and that's cool, and you're gonna show your friends, and you're gonna get the performance model, and you're gonna step on the pedal and have head snap back, and that's worth $20,000. Well, fair enough. Like I can't say that that's a bad decision. Honestly, that sounds kind of cool, but
compared to like some of the premium upgrade packages people put on things, and you get video players in the back of your headrest for another $10,000. It's like at least the electric car gives you some functionality.
Neck snapping.
Is that still a thing in the era of like cell phones and tablets? Is there still cars that have?
I was telling you,
screens.
Sony is coming out with a car, and Sony's car explicitly has high definition screens in the back of the headrest so that people in the back can game. It's not even a joke. It's crazy.
That's ridiculous.
I remember like back in the day, in like the early mid 2000s, that was like the cool thing. Like the cool minivans had like the headrest TVs. But like ever since smartphones came out, I hadn't heard a lick about that. Like I've never seen that advertised ever.
I don't think they advertised them. They very well might not be putting them on things, but it was brought back to my mind by the fact that Sony explicitly is making a car that will have those back in it.
A car with like gamer aesthetic. Oh my.
Oh yeah.
No.
It's like it's going to be able to play PS5 games. It's like they're ready to go. Like they're going full to. Somebody went on a road trip in 2004, and his buddy had the PlayStation briefcase that you could open up and play in the car, and he just never got over it. It was just
exactly.
Too cool.
Now he's an engineer for Sony.
Yeah, how do we differentiate our Sony car? I don't know. Screens in the back of the.
Hey, we make TVs. Might as well. This is cross-functional with our other teams. Like it's called synergy.
How does that
student knows this?
Impact battery charge level? Like you know, that's the all the test drivers are going to have to do the benchmarks. Like, oh, if you crank the TV,
You don't want to be playing too much God of War because it drains the battery life
You
real
lose.
bad.
15-kilometer range for every hour of God of War you play. What a time to be alive.
Yeah.
All
You
right.
guys have any
Yeah. I was gonna
other
say, anything else?
final thoughts? I don't know. That's pretty much all my final thoughts.
Yeah, you basically summed up what I was thinking as well. Like, I think for my own personal life, I'm gonna wait and see how the rest of the market goes, and hopefully there's some great advances in the battery tech that makes them quite a bit cheaper. And at that point, then I think it's well worth considering it. But or if oil just spikes up really hard, it's gonna stay there for quite a long time, then to me that makes more sense to then switch over to electric or plug in an electric or something. But in the meantime, just gonna run the old combustion engine till she goes.
Well, I think we need a bit of financial advice at the end. And this is the play, is you invest in oil stocks because oil's going to the moon. Then when oil goes to the moon, gas is too expensive. You sell your oil stocks, you buy an electric vehicle. Foolproof.
You've just invented hedging.
Yeah, I do my best, come up with these novel ideas nobody else could ever think of. Don't know how I do it.
Yeah, I think you should go work on Wall Street. You're gonna become very rich. All right, well that's it for me.
Peace.
Peace.
Peace.